Okay, now we're recording. Okay, so data cleaning, yeah. So wrangling and data cleaning, which is sort of this first section of the project pipeline, are actually probably going to be the majority of what you do as a data scientist if you're ever working in like a practical setting or in an industry setting. So if there's any one specific lesson that I want you guys to pay attention to, it's going to be this one, because a lot of the bulk of data science and data engineering and research stems from the process of cleaning through data. And the reason we do this is because you might have a bunch of fancy models or really sophisticated ways of predicting using your data, but none of it's going to matter if your data isn't in the proper format. In the first lesson, if you were here and you saw that, we kind of went over the idea that machine learning is essentially a way of figuring out relationships between features of data, which hopefully helps us to make some sort of inferences about relationships and occurrences in nature, and how we deal with missing values determines, in some ways, some of the underlying inferences we make about data. So I like this particular example because it really exemplifies why it is important that we choose a good data set and that we take care to make sure our data set isn't biased. And you're going to hear this term come up a lot if you're ever studying, I guess, the ethics of data science and the importance of like setting up your project, because a lot of misunderstandings can happen depending on the data set you start out with. So like in this scenario in particular, say, for example, you're trying to teach either a person or a machine what a car looked like, just based off of image data. Say you have like a huge data set full of different images, like, and say this is like your subset of your data image set, for example. Some of these are just non-car images and a lot of these are car images, but what you'll notice here is that each of the cars in these photos is very blue. And say you ran this through like a machine learning model or something, and you get the result, and from then forward, you try to have that same model predict what a car is, depending on the images you feed it, and all of a sudden you realize that it doesn't recognize anything other than big blue objects, because that is all the data that you give it. Essentially, that's the problem here. You don't actually know if your model is detecting what a car looks like or what a big blue object is. Okay, so like it wouldn't be able to tell if, say, like a green truck is a car because it's not blue, which is what the data is. There was actually a fairly recent practical example of this kind of underlying bias. And it was with this essentially an image learning software that someone came up with that essentially took very low resolution images of people and sort of transformed them into a more higher resolution, more filled out version of the picture. The problem here is that when they ran a picture of Barack Obama, which is on the left here, through this learning algorithm, they actually ended up with this image of a white man, which is clearly very inaccurate as compared to what the original picture would look like. The problem here was that their data set, whatever data set they were using to train their model, was likely very biased towards non-minorities. So in essence, the learning model itself became biased because the data set was biased itself. For the few of you who just joined, if you're looking for the intermediate pipeline, you are in the right place. If you're looking for the beginner pipeline, the links to that are in the chat, and the project pipelines are being held in person. So yeah, link for the beginner pipeline. I'll just go ahead and like put it in the chat again. There you go. So when I say cleaning data, what does that really mean? A lot of the time when we're cleaning through our freshly acquired data set, what I'm actually talking about is how to deal with missing values. And missing values you've probably seen before in your past coding experience. Missing values might be something like none or NA, or in this case, NaN, which stands for not a number. And that's essentially Python's own floating integer type description of a missing value. If you look at this data frame here, this is again another excerpt from the Titanic data set that we've seen previously. And if you look at some of the features, some passengers are not, they don't include some values. Like for example, here in row 888, which is passenger 888, Miss Catherine Johnston here doesn't seem to have an age associated with her record. And that's what we would consider a missing value in this case. The next question we kind of have to ask ourselves is, why not just have our data set stay as it is? Why do we even have to change anything about it at all? And the thing with that is that a lot of machine learning models can't really work with data that doesn't include all of the values. Like for example, if we go back to this table we had here, if we had a model that used the age feature of each of the data points to make a prediction, and it came across this missing value here, it might not work at all. And that's obviously not something we want to happen if we're trying to use it to come up with the result, right? So obviously we're gonna have to deal with that ahead of time if we don't want to run into these problems. Another thing that we might want to consider with dealing with missing data is that a lot of the time when we're collecting data from the real world and doing experiments and things, a lot of that data isn't going to be perfect. And at the same time, a lot of these entries that otherwise have missing values, like this one passenger here, could provide some useful information for a model. So we don't just want to get rid of the entire entry just because there's maybe one or two columns that have a missing value. So by dealing with these missing values, we can actually preserve some of the data we would otherwise have had to throw out. And that's definitely something that will be to our benefit later on. And there are two basic ways to deal with data that's missing. And in this case, we have both deleting and imputing values. And those are pretty self-explanatory. For missing values, we can either just get rid of them entirely. Like we said before, we could just get rid of entries or features that have missing values, or we can impute values for those. And we'll go over a couple different ways of how that works in a second. There are a lot of different methods for imputing data that are a little more complex than just taking out a few rows or taking out a few columns, but it also doesn't have to be that difficult. They're pretty simple ways. If you take a look at the notebook, you'll actually see that we do some basic data imputation. So definitely take a look at that. And there are some actually more sophisticated models out there that will sort of do your data imputation for you. We won't go over those today, but they are out there. There are very sophisticated models that will kind of do a little bit of this data pre-processing for you. Yeah, if you look in our intermediate Slack channel, I just posted the link to our week 3 notebook. And that one is the one on like intro to machine learning. If you guys ever have problems opening that or finding that, definitely let me know. Okay, so as far as imputation goes, there's a pretty simple way to do it where we just take either the mean, median, or mode, or some other like principal statistic of a certain category, and we impute that for every missing value of that same group. And what that means is, say for example, we have this table here, which contains a bunch of different people, and each of these peoples has a sex associated with them, as well as the number of hours of sleep they got during the night and their relative stress level. And these are the 3 different features we have for each of these entries. And you'll notice that some of these hours of sleep here are missing for some people. One way to deal with this is to take this column here, hours of sleep, and take the average of all of these numbers here that are present, and say whatever that is, say the average is like 7 or something, and we would just replace each of these NaN values with 7, because that's on average what the value of sleep is going to be for all these people. The benefit to doing it this way is that it's really easy. It's really easy to code. And it's a very fast way of taking your missing values and fixing that for yourself. The possible downsides, however, are that we may be introducing some degree of bias to our data set. Like we were discussing earlier with some of the prior examples, we might be introducing some bias in this way. We'll go over that a little more in detail. Yeah, so this is just a continuation of that same table. Again, all these missing values could easily be replaced depending on the surrounding data points. So deleting data is another way of dealing with missing data points. There are some cases in which this might be more beneficial as opposed to imputing data. But there are a couple general rules to abide by when deciding whether or not you should delete or impute for missing data. If you have, for example, a large amount of missing data in one particular feature or entry, you can use 70%, like it says here on the slide, as like a rough guideline for that. It's really up to you to make that call, though. So bring it back to this one table that we had. If you take a look here, you'll see that the cabin column here, which is one of the features of these passengers, has quite a few missing entries. Like at least every other passenger in this subset of the table is missing an entry for cabin. So what we could do in this case is just eliminate this column entirely. Just say, you know what, we're not going to use cabin in our model at all. That might be one way to do it, since if you tried, you can't really take, for example, the average of a categorical variable in this case, and that wouldn't really work for you. You can also, on the other hand, delete rows. For example, if you had a passenger that didn't have a lot of different features listed, that didn't have like an age or a cabin or anything like that, you might just say, you know what, we're just going to take this entry out and not try to deal with it at all. And this is usually something you would do if you find that your data points are missing completely randomly. And we're going to explain what that means in a second, but data can sometimes be missing completely randomly, just normally randomly, and not randomly. There are a couple different ways that is different. Does anyone have any questions on any of that? Okay, if not, we'll just continue. So missing data happens in a couple different ways. Sometimes they're associated with some, sometimes there might be a reason as to why data is missing, and we'll go over why that is in a second, but we can generally classify missing data into 3 groups: missing completely at random, missing at random, and not missing at random. So it might not seem very apparent at first what the difference between missing completely at random and what missing at random is, but we'll go over that right now. When we have data that's missing completely at random, what we're referring to is the fact that there's no relationship between the data itself and why some points are missing. Like, for example, here, there's no real apparent reason as to why these 2 values are listed without a value. We can assume they were just missing due to some random error. or some sort of imputation issue when whoever was researching maybe put in this data into their system. Missing at random is a little different, and it's a little confusing, but bear with me. Missing at random refers to missing data points that are not necessarily due to the values that are missing themselves, but rather perhaps a different feature in the data that might be causing it. Evelyn says hi. Yeah, so for those of you who may have just joined late, this is the intermediate pipeline. If you're looking for the beginner pipeline, links are earlier in the chat. If you need me to post them again, I will. But yeah, links are in the chat for the beginner pipeline. Project pipelines are being held in person. As for the summary as to what we're talking about, today we're doing a little bit on data cleaning. So essentially like data pre-processing. Last week we talked about visualization a little bit, and this is just kind of an overview of how to deal with missing values in data. Does that make sense?
Yeah, thank you. And are we going to use Python to process the data?
Yeah. Are you in the intermediate pipeline Slack channel?
I'm not sure because I didn't attend the last meeting either.
Okay.
So yeah.
Okay, so definitely join the intermediate pipeline Slack channel. You can access that if you're a part of the data science Slack, like for our club. Are you a part of the Slack for? Okay. So you can go to our Slack channel, like our overall club Slack channel, and add like the sub channel for intermediate pipeline.
Okay.
Does that make sense?
Yeah, thank you.
Okay, definitely stick around and let me know if you can't find that.
Okay.
I post the links to everything there. Okay. Okay. Continuing on, missing at random basically describes data where it's missing as a result of some other phenomena in the data. For example, in this case, you'll notice that each of the missing values for sleep is only associated with the entries that are male. And we could take a guess as to why this would be true. Maybe males, for some reason, are less likely to log their sleep in this particular data set. Like I said, there's some association, perhaps, between why the points are missing and the features themselves, but not the actual value of the sleep. And finally, not missing at random data. In this case, the reason as to why each of these values is missing depends on the value of the variable itself. And what I mean by this is if you take a look at this column here, you'll notice that the other entries in this table that aren't missing have values of sleep that are very high, 7, 8, 9. That's a pretty good night's sleep, if you ask me. But the other values here are missing, and we could guess, perhaps, that the reason these are missing is because these three people in particular, got very little sleep. Like say, on average, they got much fewer hours of sleep than these other three people in the table, right? And if you only get 2 or 3 hours of sleep, maybe you're embarrassed or something to log that in this particular example. In this case, the data is not missing at random. There's a very clear reason as to why people aren't logging their data. That's because they had really low values of sleep. There are different ways of dealing with missing values. If you can't quite tell if your data points are missing at random or not at random, there's one way of figuring out whether that is the case or not, and that is through hypothesis testing. We're not going to go over it in this lesson, but if you take a look at the slides later, you can check this out a little bit later if you are interested. So when it comes to doing projects, which you'll all, I hope, be doing in the future, when it comes to dealing with missing values, it's not really worth worry too much about if you're doing it the right way or not. The most important thing is considering these two questions, and that is, why is this particular entry of data missing? And is this feature or row that I'm dealing with going to be important for what I'm trying to do? And as long as you can think about those two types of things, you'll likely be able to make a pretty sound decision when it comes to your own project. So yeah, when it comes to this data set again, there are two things we can do: drop the rows and impute means. For example, these are all the particular measurements if you were to calculate all these different hours of sleep, and you would be able to substitute these different missing values for the base statistics that you have here. Briefly, to touch on training and testing again, we'll be going over this a little more in detail next week when we start talking about regression, but when you partition your data set, you're likely going to have missing values in both your test and your training set, since they both come from the same set. What we want to watch out for when we're cleaning our data is we want to make sure that we don't impute any means or any base statistics into our test set that came from our training set. And the reason for that is that's an example of what we would call data leakage. And what I mean by that is if we're using a model or something to predict the outcomes from our training set and evaluate that against the actual values of our test set, and some of our test set values have been imputed with means and distributive like classifiers from our training set, we're actually introducing some of the training set information into what is supposed to be completely separate. And if you don't really understand what that means at this point, that's totally fine. But the main takeaway here is keep your train and test set separate. And when you're cleaning your test set, make sure to keep the values from your train set separate. Okay. Again, we'll go over this in more detail in later weeks. So yeah, just to illustrate that a little more, if you were to calculate, for example, the means of the amount of sleep in your training set, you wouldn't want to impute any of those values into our test set missing values. Generally, a good rule of thumb when you're doing projects, set your test set aside and leave it aside. Don't mess with it. Don't try to do anything interchangeable. You might end up with data leakage without even realizing that you're doing it. And I'm going to go ahead and wrap this up now. These links to both our notebook and these slides that you have here are already posted in the intermediate fall 21 intermediate channel. So go ahead and check that out. Again, let me know if you can't access those for any reason, because we are definitely going over different data cleaning methods in this notebook. So if you want to practice a little bit of that yourself, definitely take some time to go through this notebook. And yeah, that's all I have for this week. Thank you guys for coming out. If you have any questions, I will stick around a little longer, just in case you guys have any questions about anything.